In this video, we're going to talk about proteins. This is going to be a general overview of everything we need to know for proteins. So the first thing we're going to talk about is the structure of protein. Then we're going to talk about the things that are affecting the structure of protein and how we regulate the protein folding. So first, we have our structure. Our structure consists of primary structure, secondary structure, tertiary structure, and quaternary structure. Our primary structure is a linear polypeptide chain and is joined together by a peptide bond with an N-terminus and C-terminus. Our secondary structure is going to form alpha helices and beta sheets, and they mainly consist of hydrogen bonds. So we have our alpha helices here, and we have our beta sheets. For a tertiary structure, we're going to combine these alpha and beta sheets, and we're going to add some more folding using disulfide bonds, covalent bonds, non-covalent bonds, and hydrogen bonds to form a subunit. These subunits will then combine and make up a quaternary structure, also known as a domain. So in this example, we have alpha 1, beta 1, alpha 2, beta 2 combining to form a domain or quaternary structure. But how do these structures get affected by different things happening in the body? For example, temperature and pH is going to cause denaturization. So at extreme levels of pH or extreme temperatures, we're going to have denaturization of our protein, so that it's not going to function properly. Another thing is urea. Urea can break these disulfide bonds located in the tertiary structure, and it can cause it to unfold into its secondary structure, and if severe enough, it can go all the way to the primary structure. Another thing affecting the protein structure is going to be proline, glycine, and any bulky amino acids. The way that the protein folds, proline, glycine, and bulky amino acids can affect the way that it folds by giving it room or taking up room. The last thing we're going to discuss is regulation. So regulation is done by chaperone proteins and heat shock proteins. So the chaperone protein is basically a compartment where the protein can fold properly. It's also going to monitor the way that it folds. If it doesn't fold properly, then it's going to go into protein degradation by proteases. If it folds correctly, then it's going to form into the subunit. The subunit can then combine with other subunits to form the quaternary structure, or if the subunit can function on its own, it will go into its correct pathway for exocytosis or to the proper location within the cell. The last thing we're going to discuss is heat shock proteins. Heat shock proteins, it's in the word, it basically helps prevent the protein from degradation at high temperatures. So there's these heat shock proteins that will prevent it from degrading in high temperatures while it's folding. If it is too high of a temperature, you will still have denaturization, but these heat shock proteins allow these proteins to live a little bit longer at extreme temperatures. For example, if you're having a fever. Please let us know what you think about this video by leaving a comment or hitting the like button. Don't forget to subscribe to get notifications of our upcoming videos. We'll see you in the next one.